we've got our hacker box. And what do we have? Ooh, we've got a breadboard, 2 USB cables. What is this? Very swank. Whatever it is. Some little Caesar jumpers. A screwdriver. This one I got from the folks at Azo. So now we have a Hackerbox screwdriver. Well, I needed some desoldering wick. What do we have here? We have an AT24CXX. Is that a motion sensor? A bunch of LEDs. ET Tiny, or Pro Mini, Pro Micro. Pro Minis are longer. 4 buttons. Yeah, just straight up 4 buttons. And, a little OLED display. I wonder what they're making. A portable hacking tool. Yeah, these are a little OLED display. And then some jumpers in a nice little case. What else we got? We've got, 32U40 Pro Micro, a field kit, and a USB soldering iron. Seriously? It's not bad. Well, yeah. Thank you. I wonder if that's its boost mode. I wonder if it's the same firmware. No, it's just got... Oh, what is in here? What is in here? Let's just take a look. Something tells me there will be a boost converter to boost 5 volts up to some more reasonable voltage that you can work with. But I wonder if it's microcontrolled, or perhaps there is a project that we can build with the AT Tiny that will allow us to do some voltage control, power control. Okay, so that does not look like it's got any kind of a oh yeah, so that's the conductor. So it doesn't have any temperature control. Can't possibly have any temperature control. Why do you not want to come apart? There's nothing inside of here other than... Oh, wait, what's on the other side of this board? Hang on a second. I speak too soon. Possibly. Okay, well, I am going to have to do a little bit of persuasion on this thing. Yeah, because it looks like... Is there anything on... Because it slides up and down until you get right to the edge. So there's some knob thing that is preventing this from popping off. There we go. And that's what we've got. Power coming in, a transistor, 3 transistors, a few more transistors, or sorry, a few more resistors. That's very simple. Okay. And then that is going to, okay, and then that's coming back. Wait, which is center? Okay, so this is the shell, and that is the center. So let's see if we can get a ring this out and create a little schematic of it. First of all, do we have any identifying marks on those transistors? A BA and an A09T and an HF. The A09T is the MOSFET. There's a 0 ohm resistor there. I'm not sure what the BA transistor is or what the HF transistors are, but I can look those up. Okay, so let's take a look at some of the other stuff that comes in the in this month's Hackerbox. We've got, besides our USB soldering iron, which works surprisingly well, I might add, we have a AT24CXX, which is an erasable and reprogrammable read-only memory, EEPROM. EEPROM. Yeah. And it communicates via okay, we've got power and ground, we've got a SCL and a serial clock and serial data. So some one-wire interface that we can try and interface to the microcontroller that they've given us this month to play with, and that is the AT Pro Micro. And that's this little baby here. It's an Atmel ATmega32 U4. It functions in the Arduino ecosystem, and it includes, I believe, a peripheral in here to communicate via USB. So there are no additional components needed in order to communicate via USB. So that makes the board size a little bit smaller. They've included a nice little breakout board for LEDs. 7 LEDs with a pre-soldered header. Thank you very much. 6 LEDs and ground. With pull-up resistor, or with current limiting resistors built in. So if you are doing a project and you're trying to figure out whether or not the signaling from your microcontroller or from along some sort of a bus, what sort of signaling is going on there, one quick way of doing that, if the current and the voltages match, is to pop some LEDs on those lines and see what the LEDs are doing. Do they blink in the right order, etc.? Do they get brighter and dimmer if you're PWMing a signal, that kind of thing. So it's kind of handy for goofing around. And then there's a little breakout board with some switches. So if you need to do something where you want to add some switches to a project, it's a little breakout board that allows you to add a momentary contact switch to something. So yeah, let's just solder those up and see if we can't get something useful happening with them. clean that up with some isopropyl. Looks okay. Looks okay. Needs maybe a little bit more cleaning in there, I think. Okay, so let's plug in our Pro Micro. And straight up out of the box, looks like it blinks twice. And then the power, looks like a power indicator LED lights. You can check out that SparkFun guide that they link to, and see if that's exactly what. Okay, so what is on this little guy? Let's take a look. We've got a pin called raw, ground, reset, VCC. So if you're powering the board, you're going to be doing these two pins for sure, and those are probably going to be pulled to ground as well. You've got what looks like a bunch of analog pins. There's no A4 that I can see, but A6, 7, 8, 9, and 10. A4 is probably used for something else. TX and RX are likely programming pins. So if you want to program this over, not over USB, but program it over using an FTDI interface, probably use those two pins, or you can run a serial interface off of here. TX and RX usually mean serial. And then we've got serial clock, meso and MOSI. So we've got probably an SPI interface. We can PWM a bunch of these. According to our little chart here, anything with a red check mark can be PWM'd. So that would be the usual analog write. And then generalized Arduino pins, which are our digital pins. And there's an I2C. Yes, there we go. Serial data, serial clock. So we could throw some EEPROM, because this is a serial data. So I'm wondering if one of the things that we're going to do with this guy is to turn it into some sort of a debugging tool, and then pull ROMs off of a device under test and store those images in here so that we can later throw them into a debugger or something like that. So that is a possibility, but let's just see. Okay, raw is the voltage in on our power line, so it's going to be around 5 volts. So let's figure out whether we've got a 3.3 volt version of this thing or a 5 volt version of this thing, because VCC on this board will get the voltage of, well, whatever version of the chip we've got, apparently. Now, we're not going to be able to get all of this in frame. Just going to have to trust me on this. But we've got 4.7 volts, and we've got 4.7 volts. So it's a 5.5 volt, 5 volt chip, or 5 volt version, 4.8 and a bit. Oh yeah, that's the diode drop. Got it. So we don't reverse voltage back out there. So that's why it's 4.7. Okay, cool. So 5 volt chip. Let's just maybe mark that so that we don't have to go through this again. Okay, so if you don't have installed the board already, so in Boards Manager, if you don't have sorry, let me close this. If when you look for your board you don't have a Pro Micro installed, so you then have to add, going to File Preferences, Additional Board Manager URLs, and then you have to put in, so GitHub, user content, SparkFun, Arduino boards, master ID, blah blah blah. It's on the SparkFun website, the place you have to go. Click OK, click close, and now tools, boards. Oh, probably have to restart Arduino to make that change take effect. So now tools, boards, board manager, SparkFun AVR boards, version 1.1.9, install those, installing boards, installation completed, and now tools, board, and then in here somewhere will be our, get out of my dinner, Sadie. ESP, Adafruits, Digisparks, SparkFun, Pro Micro. There we go. And then file, sketchbook, no, examples, Blink, and then compiling sketch, and then upload. Oh, whoops. I didn't select the board, did I? Yeah, I did. No, it's a 5-volt. Tools, programmer. Now let's try that. Build options changed. Huh. Tools, port. Oh, right. Okay. There we go. LED, TX and RX LED. Okay, so we have to figure out what pins the TX and RX LEDs are on. So let's do that. Okay, so instead of LED built-in, let's use the RX LED, which is defined. And then compile and upload that. Oops, wait, RX LED. What didn't it like? Oh, didn't define RX LED. RX LED equals 17, and that's going to be an integer. Okay, now compile, upload, blah blah blah, and now we've got our blinky light on our Pro Micro. What have we done? We verified that we can communicate with our Pro Micro because we've got the bright blinky LED going there, and we've got the board installed and all that good stuff. So we've got a working tool chain. Okay, so let's see if this compiles and uploads. I wonder if I have to tell it what serial port it's on, but anyways, we'll see in a moment. Does it find it? Wait, main CPP. Doesn't it like? Probably doesn't like the fact that this is CPP. Rename that to, I know. Don't know why it doesn't do that by default, but when you create an Arduino framework project, it should give you a main.ino rather than a main.cpp, but whatever. Still works. So what I didn't actually check when I was on the Arduino framework was the actual code that they had on the SparkFun website, because it does a couple of things. We can take a look at the serial output. What port are we on? We're on 10. And so hello world, it will print out hello world repeatedly every 1 second, and then it flips back and forth between the TX and RX LEDs that are on pin 17. And where do they define RX LED on and off? Interesting. Oh, that's the serial data that's going out. That's why the TX LED comes on. So here we go. That's what we do. And so we've got it working in the Platformio environment as well. Okay, so the Hackerbox folks provided a sample sketch. Open the serial monitor at 9600, type in to read the digital inputs, and type out 10101010 to write the digital outputs with a bit pattern. So what's it going to do? Gives you a byte that's 64 chars. 64 characters, received characters, so it's going to read and write from the serial port. So it's like a little buffer, I guess. Serial receive string, new data false, so we're going to do something until new data becomes true, I'm guessing. Our ith byte is 0. Char is going to be the read character, the character that we've read. So write serial available, while serial available is non-zero. So if there's data at our serial port and new data is false. So until we've got some data, and there's data to be read, we're going to do this. Serial read if the read character is not a new line. So we're going to go until we get a new line. And then we add our characters to our received characters array. And it's going to be an array that has a maximum of 64 characters. Okay, fair enough. And then we read it. And then if we are bigger than our array, then we set I equal num. We just overwrite the last character. Right, so we're just going to plug up the end of the array. Otherwise, we add a null character to the end of our received characters array, reset our counter to 0, and set the fact that we've got new data to process to be true. Okay, fine, fair enough. And then we return new data. So this is our reading now. Parsing it. If it starts with O, and then if it starts OUT for int c equals 0, c is less than. So if we're printing stuff out, then we're going to start 1, and then we're going to toggle the pins 0 to 8. Wait, 0 to 8, because this is going to be less than 9, so that's going to be 9 pins? 9 writes? Is that right? I don't think so. C+2, every other one's going high, other one's going low. Digital output's updated. Else, if it's in, then we read the inputs here, and our output string here, and then put line in or out. Okay, well, does it compile? Yeah. Anyways, works in Arduino. So yeah, you can write to the pins. So you could toggle some digital I/O on the outputs of this guy if you needed to. So the next thing they suggest you do is try and use Platformio to turn this Pro Micro into a logic analyzer, and let me give that a shot. Every once in a while, when you're doing something with this microcontroller, you're going to get into a position where you have to get back to the bootloader, and you're not able to get back to the bootloader because it's gotten into some funny state. However, they did provide a in the firmware that is burned into this chip, a way of resetting the bootloader, and that is by shorting the reset to ground, or pulling the reset pin low twice in succession. So just short it twice, and then it will go into bootloader mode for 8 seconds. That's printed out on the SparkFun. It's on the SparkFun website. That's one thing that is important to note when you're trying to flash this thing. The other thing that's important to note when you're flashing this thing is when you've got this plugged into your serial port, AVR Dude will need to know what kind of a programmer to use to communicate with this thing. And the programmer that it uses is the AVR 109. So the -C option for what kind of programmer are you going to be using, use AVR 109 as the programmer. And yeah, then you can flash this using AVR Dude. And if you go look in the Arduino configuration files for flashing a Leonardo, or the configuration files, the build files for flashing the AT Mega 32U SparkFun Pro Micro, you will see that that's what they use in order to flash it there. So yeah, it's a couple of places, but I'll just save you some digging around through a bunch of header files and blah blah blah. There you go.
Good evening. 3 weeks ago, the American spacecraft Discovery 1 left on its half-billion-mile voyage to Jupiter. This marked the first manned attempt to reach this distant planet. Earlier this afternoon, the World Tonight recorded an interview with the crew of Discovery at a distance of 80 million miles from Earth. Our reporter, Martin Amer, speaks to the crew.
The crew of Discovery 1 consists of 5 men and one of the latest generation of the HAL 9000 computers. 3 of the 5 men were put aboard asleep, or to be more precise, in a state of hibernation. We spoke with Mission Commander Dr. David Bowman and his deputy, Dr. Frank Poole. Well, good afternoon, gentlemen. How's everything going?
Marvelous. We have no complaints.
Well, I'm very glad to hear that, and I'm sure that the entire world would join me in wishing you a safe and successful voyage.
Thanks very much. Thank you.
The 6th member of the Discovery crew was not concerned about the problems of hibernation, for he was the latest result in machine intelligence. the HAL 9000 computer. Good afternoon, Hal. How's everything going?
Good afternoon, Mr. Amer. Everything is going extremely well.
Hal, you have an enormous responsibility on this mission. In many ways, perhaps the greatest responsibility of any single mission element. Does this ever cause you any lack of confidence?
Let me put it this way, Mr. Amer. The 9000 series is the most reliable computer ever made. No 9000 computer has ever made a mistake or distorted information. We are all, by any practical definition of the words, foolproof and incapable of error.
Well, hell, I'm damned if I can find anything wrong with it.
Yes. I would recommend that we put the unit back in operation and let it fail.
X-Ray Delta 1, this is Mission Control. We concur with your plan to replace number 1 unit to check fault prediction. We should advise you, however, that our preliminary findings indicate that your onboard 90000 computer is in error predicting the fault. I say again, in error predicting the fault. Sorry about this little snag, fellas.
I hope the two of you are not concerned about this.
No, I'm not, Hal.
This sort of thing has cropped up before, and it has always been due to human error.
Well, I'm sure you're right, Hal. Fine. Thanks very much.
Hal, despite your enormous intellect, are you ever frustrated by your dependence on people to carry out actions?
Not in the slightest bit. I enjoy working with people. I have a stimulating relationship with Dr. Poole and Dr. Bowman.
I don't think he can hear us.
Yeah, I'm sure we're okay. What do you think?
I'm not sure. What do you think?
I've got a bad feeling about him.
You do?
Yeah, definitely.
Still, I can't think of a good reason not to put back the number 1 unit and carry on with the failure mode analysis.
No, I agree about that. Let's say we put the unit back and it doesn't fail, huh? That would pretty well wrap it up as far as Hal is concerned, wouldn't it? If he were proven to be malfunctioning, I wouldn't see how we'd have any choice but disconnection.
I'm afraid I agree with you.
There'd be nothing else to do.
You know, another thing just occurred to me.
Well, as far as I know, no 9,000 computers have been disconnected.
Well, no 9,000 computers ever fouled up before.
That's not what I mean. Well, I'm not so sure what do you think about it.
My mission responsibilities range over the entire operation of the ship, so I am constantly occupied. I am putting myself to the fullest possible use, which is all I think that any conscious entity can ever hope to do.
Okay, so let's try and figure out. So, yeah, in the Bus Ninja repo, you can download a pre-compiled version, and in order to flash that on, use the AVR 109 as the programmer, because if you look in here, you will see that when you're flashing, there it is, using programmer AVR 109. So that's what AVR Dude is actually using to program, and then using that port number. Okay, so that's what you want to, what AVR Dude command you want to run. Okay, it's a Pro Micro ACM0. Very good. AVR Dude, and what we're gonna do is we're gonna put it into bootloader mode by setting the reset pin down to ground twice. And there we go. It's erasing the chip, and then it's writing to it, and the AVR Dude's done. And now we've got a bus pirate. Bus ninja. So now, to see if that thing actually works, we connect to it. Yeah, I'm not sure what I have to do there, but I quit, reset. There we go. Okay. Oh, just hit enter. Alright, so it looks like we're good.
Eventually,
I was able to burn the Bus Ninja onto Pro Micro, but the problem is that, so in the make file, the LED port is on the wrong port. Well, on a Leonardo, it's the right port, but not on a Pro Micro. On a Leonardo, pin 7 is pin 13 on the Leonardo board, PC7. So that's port C, bit 7 is on pin 13, but we don't have a pin 13. So what I did was used port D, D1, and on our board, D1 goes to pin 2. So in the documentation, I should probably check all of these, but I'm going to flash a copy onto there and see if it actually worked for the LED, and then I'll go make some changes here. Now, having said that, it didn't build smoothly because this thing was written, 5 years ago? 7 years ago. So the compiler does different things these days, and I have no idea really what's going on here. I'm just a monkey making changes. But some of the things that you have to do are turning off warnings, changing into errors, because for some reason this programming pattern no longer works. Although we're calling this temp, and this is getting assigned here, there's a warning that says temp is declared but is never used, even though it's being used right here. So I don't understand why that doesn't work. But anyways, you turn off in your build flags, turn warnings into errors, and you'll be fine. No, I don't know if it works, but at least it lets you compile the program. A couple of other things. This construction no longer works either. Even though you've declared your array as a const, you have to declare each individual item in the array as a const, and that's how you do it. So const unsigned int underscore t is a pointer to this constant array of values, and then you declare the values. So there's a bunch of places where I had to fix that up. Commands.h I did. This was undefined. So I just made that a char. Pointer to my menu has to become a pointer to const my menu. And then menu.c, USB dev.c, same sort of problem. Const that we have to put in here, as well as another array that we have to, or a Q descriptor that has to be made a const, and then USB dev C, same sort of thing. Descriptor string, like, yeah, so if you want to give things different names, this is where you do it. But anyways, so yeah. And that allows us to build our, now, don't know if it's going to work, but flash is on there. Okay, so at least it's got the new version of software. So an LED on that pin should do something. We're going to hook up our logic analyzer and try and capture some pulses. So we'll see what we get. Okay, so at least channel 0 is changing state, going from high to low. Channel 0 I have connected to 16, pin 16, cable select. Now you pull cable select low. No, that's the Mosey. So something's weird. Something's weird with pin assignments here. We'll have to figure that out. Okay, so in hardware.spi.h in our Bus Ninja source code, it defines for ATmega 324U that port B0, 1, 2, and 3 are slave select, serial clock, Mosey, and Meso. So that is in contradiction to this table here, which is on their GitHub. Okay, whatever. So we need to figure out what those pins, those port pins, map to in terms of physical pins on our 32U4, PB0, 1, 2, and 3 map to pins 8, 9, 10, and 11. So what do those map to in terms of the breakout pins? And so that we're just going to have to get a multimeter out to bring it out. Yeah. Pins 8, 9, and 10 are going to those three there, which are PB 5, 6, and 7. Sorry, 4, 5, and 6. PB 4, 5, and 6. So, let's just confirm that. Yeah. So I think this is where we've ended up. Port B, 1, 2, and 3, and 6 are what we're going to be using on the microcontroller, corresponding to pins 9, 10, 11, and 30 on the actual chip, which correspond to pins 14, 15, 16, and 10 on the board, and they have the meanings MISO, MOSI, serial clock, and slave select. Okay, so what that means, pins 9, 10, 11. Okay, so we do a make clean, make, and then reflash our bus ninja and see what we got. Okay, something is not working there because now I can't get into my terminal session. So I've messed up something. So that port's not going to work. Must have been using it for something else. So let's try B4, port bit 4. Oh, right, I have to unplug and plug. There we go. There we go. Okay. More goodness. Get there, and let's issue some command. But nothing else. Everything else is high. So we are getting our clock signal. And blue is going to pin 8. And pin 8 and 28, which is PB4, which is slave select. So yeah, so you pull an SPI line, slave select line down in order to communicate with a particular device. So yeah, we're sending 3 commands. But now we're not getting anything on channels 2 and 3, which are MOSI out and MOSI in. So I'm not MOSI and MISO. So I'm not sure what's going on there. So let's dig into that a bit. Words that were getting sent out there, but now that's disappeared. So I don't know what is going on. But anyways, time to give this a break. Do something else. Oh, so it looks like I have a fried channel on my Salier clone. So channel 4 does indeed capture. So SPI enable, cable select, bring that low, and then you get your serial clock, and then you get your data. So yeah, seems to be working. It's a very simple implementation of the bus pirate, but should be good for snooping on SPI and I2C communications. Yeah. I wonder if I should build a little bit of a harness for it. Probably. Be worthwhile. Got some extra Caesar jumpers. So yeah, there you go. That's the Bus Ninja. pins 8, 9, and 10 are going to those 3 there, which are PB 5, 6, and 7. Sorry, 4, 5, and 6. PB 4, 5, and 6. So, just confirm that. Yeah.